So far we've been talking about if I only have one variable that I've collected. So in this case now in chapter 4 we're going to talk about having two variables. So you want to know if you know one value for a variable, can you try to predict what the value for another variable might be? Okay, so we're going to explore the associations between two variables. Okay, again, you're going to have to be able to describe what we call a scatter plot, and we'll talk about what a scatter plot is as we go through here. Okay, you're going to understand how to use the regression line. That's just if you're going to try to predict some value from data that you're given. Okay, and how to interpret the slope and the y-intercept. That's a little bit of algebra that we'll do a review on. Okay, and then critically evaluate. In other words, when can you actually use this regression model? Okay, so first let's talk about seeing if we can describe a scatter plot. Okay, so a scatter plot is just where you have both an x and a y-axis. So here I have the median age of marriage for women, and here I have the median age for marriage for men. Okay, so I then plot points. So like this point here is where the age of the woman was just a little more than 24, and the age of the man you see would be almost 26, or about 25 and a half. Okay, so it's just plotted on a grid where you can read both the horizontal component, which you might be used to calling the x component, and the y value, okay, or the vertical component. Okay, so this is the example of what a scatter plot would look like. And what we want to do is we want to investigate whether we have a positive, negative, or no association between the values. Okay, so these actually, each dot in this represents for a state. Okay, so if we notice here, we can tell that in states where women tend to marry at an older age, men also tend to marry at an older age. And you can tell that because as the median age of marriage for women in that state increases, right, the median age for men will also increase all the way up to here. We have some state where people are almost into their 30s on average. Again, these are medians before they get married. Okay, here's another example of a scatter plot that has what we call a positive trend, because as the age of the car increases, the number of miles driven on the car also will increase. And again, here, this dot here would be an example of a 10-year-old car that has less than 50,000 miles on it. Okay, and you notice that we do have some what we call consider outliers, like this car here that's maybe 6 years old that has like 225,000 miles on it. And even this one here then, that's old, but doesn't have very many miles at all on it. So we can talk about what the scatter plot is. So we can see that older cars tend to have more miles than newer cars. Or you can also say newer cars tend to have fewer miles than older cars, or that there's a positive association between the car age and miles the car has been driven. Okay, so these are just some examples of sentences you could write that would describe this scatter plot and the fact that it has a positive trend or a positive association. So with a positive trend, as one variable increases, the other one will also increase. Okay. Negative trends are as one variable increases, the other variable will decrease. Okay, so this is the literacy rate and the total births per women, and each dot in this case actually represents a country. So you can see here as the literacy rate increases, right, women tend to have less babies. And a lot of times this is because this is your industrial nations and stuff, and over here you have more your third world countries. Okay, so again, some examples of how you can describe this relationship is countries with higher literacy rates tend to have fewer births per women, or countries with lower literacy rates tend to have more births per women. So we can say there is a negative association between literacy rate and births per women. You don't have to write all three of these. I'm just giving an example of a sentence that you could write. So you really only have to write one of these ideas when you're trying to describe the direction or the association that a scatter plot has. Okay, here's an example of one that has no trend, and this is actually for marathon runners. So it's for each marathon runner, it's their age and how long it took them to complete the marathon. And if you notice, like if you try to think about putting a line through, you almost just want to draw a horizontal line because there's no direction to the dots. They're just scattered all over the scatter plot. Okay, so in this case we say there's no trend between the speed and age of a marathon runner. Okay, and again, just as one of these sentences work, and you recognize hopefully that they all are actually talking about no trend or no association. We never say that one thing causes the other. So like in the previous example, I wouldn't say that the literacy rate causes the total births per women to decrease, or as the literacy rate increases, we don't say that it causes the total births per women to decrease. It's just countries that have higher literacy rates tend to have lower births per women. So don't try to use the word cause for causation or anything like that in these examples. Like back in chapter 1 when we talked about experiments and observational studies, remember we have to have an experiment before we can use the word cause or say one thing causes the other. These are not experiments for most of our scatter plots. Okay, so far we've talked about the direction of this association. Now we can talk about the strength. Okay, so the strength of association is if for each value of x there's a small spread, then we say it has a strong association. If for each value of x there's a large spread, then it has a weak association. And then you can also say if there's a strong association between your x and your y, then x is a good predictor of y, or similarly, same thing for weak or bad. So let's look at a couple of graphs that demonstrate this. Okay, so in this graph, if I pick a particular x value, let's say if I pick 65, you see how wide of a spread there is here on the y value. So you're looking at how far up and down it goes, and that's actually a fairly large spread. So we say this is a weaker association than this one. So like if someone's waist size, that might be about 30, you can see it's a much smaller spread. So think about if you were to draw two parallel lines that kind of encompass all the data here. Okay, how far apart are those two lines? The further apart the lines are that you have to draw in, then the weaker the association is. Okay, so that had to do with the strength. So we've talked about the direction and the strength, and then this is kind of what I talk about a form. So a lot of times in this class we're going to look to see if the graph is linear. Okay, so here I have the heights and drops of several roller coasters. Okay, so these are in feet. Okay, so I have a roller coaster here that's looks like it has about a 325-foot drop. That's a little over 400 feet tall. Okay, and hopefully you see right away that there's this positive association, right? And it actually has a pretty strong association because the spread in the points isn't that much. Okay, but we can also say that it's linear because if I put a line through there, most of the points are pretty clustered around that line. Okay. We'll encounter some that may not be linear, and we won't show you what to do in this class with those type of scatter plots. That's for a much later class, okay, which most of you will never have to take. Okay, so just to get help with doing this, what I want you to do is just go ahead and pause the video for a second. You're going to draw several rectangles on a piece of paper. You can even get your family members or your friends to help you draw some, okay, and then measure the length and the width of it. We're going to call the length the longest side and the width the shortest side. And then I want to make a scatter plot of the data. We're going to do that and crunch it. And then we're going to talk about describing it. So I want to actually have your scatter plot, so you're going to have to think about how you would describe that scatter plot. Okay, so go ahead and pause the video, make your rectangles, do your measurements, and then when you're done, come back and we'll go over to StatCrunch to show you how to put the data in order for you to make your scatter plot. Okay, once you have your done, go into StatCrunch. You can get there through your My Math Lab or My Labs Plus. Okay, all you have to do is click on Open StatCrunch. Okay, and then if you click where it says var1, you can rename this, and we'll call this the length. And click var2, and I want to call this the width. Okay, now I forgot which was the length and which was the width. So where the longest side is the length and the shorter side is the width. So if I come back over here, I'm just going to kind of make some numbers up. So the longer side's the width. So let's say this was 5 and 3, and you can use centimeters or inches to measure however you wanted to do it. So I've just made several different size rectangles. Okay, so now I have my data entered. If you go to Graph, okay, and you're going to choose where it says Scatter Plot. Okay, now, in our case, it doesn't really matter what you're going to call your X or your Y. Okay, so choose length for your X and Y for your width. If you actually think that the length is you can use to try to predict your width, and you use length for your X. Okay, so sometimes when you're making scatter plots, you have to think about which one you might want to use to predict the other one. And the one you want to use to predict the other one is your x, and what the one you're going to try to predict would be your y. Okay, for now we'll just leave this set to points, and you don't have to change much of any of the other things unless you want to change your point size. You don't want to do anything else through here. We'll talk about some of this later. Okay, click compute, and there's actually my scatter plot. Now I just made up my numbers. I didn't actually draw any of them. Okay, so your scatter plot you might actually be able to describe better. Okay, so that's the idea of how to at least get the data into it if you need to actually type data in StatCrunch. Okay, now if you notice on the bottom of that slide, I actually said you could make a dot plot of the ratio of the length to the width. Okay, so if I just call this ratio, oh, and actually I forgot, you don't have to do it that way. Okay, so come over here and you actually want to make a new variable. Okay. So if you go under data, we're going to compute expression. Okay, and if you tell it to build, and we actually just want the length divided by the width. So click on length and then do add column. Use your divided by and then the width and add column, and then click OK. And then here we want to call it ratio. Okay, so now it puts in the ratio of those, right? And you could actually easily make a dot plot of the ratio. Okay, and you can see if you make rectangles that are kind of like all the same proportion to each other. Okay, so that was just a little extra thing you could do, and you could actually talk about. Hopefully, you have more points than I have. You can talk about what this graph looks like. Okay, so now let's head back over to our PowerPoint. Okay, so what we just talked about there was if the shape was linear. Here's some shapes that aren't linear. Okay, so sometimes you get things like this. Okay, this isn't covered in this class. It'll be covered in more advanced statistics course. Okay, so what we're going to talk about is only if you have a linear trend. So when you're describing a scatter plot, you should talk about the strength, the direction, and the form. Okay, so here's the strength. Determine if its association is strong or weak. That's where you look at those parallel lines to encompass your data. Okay, direction was if you look to see if there's a trend or an association, and you're going to tell whether it's positive or negative. And the form, normally you're only interested in is it linear or nonlinear. Don't really worry too much about any of the other forms. Okay, and then when you do write your description, right, it's better to say the examples I have here, okay, are the good ones. The bad ones do more of looking like there's causation happening. So it's better not to write things that say because they have higher salaries, they travel further, right? It's just people who have higher salaries tend to travel further on vacation. Okay, hopefully you see the difference between the good and the bad different descriptions. Okay, it's better to use words like tend and predicted when you're trying to write your descriptions. Okay, in the next video we'll talk about how to measure the strength of the association.